Hello everyone. Today we are going to be going through the GitHub issue demo, which is located in the Kagenti repo. And through this demo, you're going to be installing Kagenti, all of the components associated with it in a kind cluster from scratch in your local computer. And then we are going to be importing agents and tools into that cluster so that you have a chat agent that will be able to obtain various information of GitHub issues in either private or public repos, depending on the user permissions. So to start with this demo, we need to install Kagenti. And as you can see, here's the prerequisite is to complete the Kagenti platform setup. So we're going to go ahead and do that. There's a bunch of different technologies associated with Kagenti. On this machine, I have installed all of that, so we can skip this section. And I've also already cloned this project and actually CD'd into Kagenti/installer. As you can see, I'm in the installer repo. And now, if you have not worked with Kagenti before, you're also going to need to populate your .env file with various API keys and credentials so that you will be able to work with the various components seamlessly. In particular, the GitHub token is going to be used for building and pushing images, as well as the OpenAI API key. I will be using that to have the agent query LLMs. And finally, this agent namespaces is the list of namespaces we are going to be bootstrapping. So this has all already been populated, and all we need to do is run the installer. So let's go ahead and do that. As you can see, the installer checks for dependencies, and we can create our kind cluster. Now it's asking us to create certain namespaces and bootstrap them. We're going to go ahead and do that. One of the relevant components that is being installed is the operator. This operator is what's going to be used to deploy the agent and the tool on the cluster. Another key component that we are installing is Keycloak, which is going to be our open source implementation of an OAuth server, in which we are going to be configuring all of our policies for user delegation of privilege. Another key component is Spire. Spire is going to be essentially responsible for providing workload identity to both the agents and the tools. Finally, we are installing the UI, from which we will be able to import the agents and the tools. And now that we have finished the install, we can go ahead and return to our GitHub Issue Agent doc. And we can go ahead and start with importing our agents and tools and interacting with the agent. All of this is going to be done through the UI. So let's go ahead and see what the UI looks like. As you can see, this URL kind of brings us to this home page from which you can see an overview of all of the sections as well as login. Let's go ahead and log in. We're going to log in with our admin credentials for now. And these admin credentials are admin, which are these are documented in the tutorial documentation. So we can go ahead and log in. We're logged in as admin, and now we can go ahead and take a look at the agent catalog, the tool catalog, and what have you. The agent catalog, we're going to see not very much because we have not installed anything, any agents, or any tools for that matter. And we're going to fix that right away. But first, just to take a look at, there's certain observability dashboards that once you run the tutorial yourself, you can go ahead and play around with. Also the admin dashboard, which will have convenient links to Keycloak. So let's go ahead and start with importing the new agent. The first thing is to select the namespace. This should be one of the namespaces you defined in your .env prior to installation. And then what we can do is select environment variable sets. In the documentation, you'll see that you have the option of either Ollama or OpenAI, and there are more detailed instructions in the documentation. But for today, I'm going to be using OpenAI, which means that I will have provided my OpenAI API key also in the .dnv in the file prior to installation of Kagenti. So I'm going to be using OpenAI, and I'm also going to be importing a couple of other environment variables. So let's go ahead and take a look where we can get those. As you can see, we have either OLlama or OpenAI, and we have a couple of preset.env files in the agent examples repo. So we're going to go ahead and we can click on import.env, put the repository URL, and now because I'm using OpenAI, I'm going to go ahead and grab this path to place in this field, and then we can click import, and then we will automatically populate some of the environment variables. Some key things to note are that the task model ID is specifying to OpenAI what model I'm using. In this case, I'm using GPT 4.1 Nano, and also the MCP URL. So instead of using the upstream GitHub MCP server, we're going to be using an MCP server locally, and in that way, we are also going to be able to control access to the upstream GitHub MCP server. So this is going to be deployed and served once we import the tool. We're setting log level to debug just to be able to see more things in the logs. And now the last three are actually relevant to Keycloak. So the first one is the JWKS URI. This is the URL from which the agent is going to be able to obtain public keys. And those public keys are going to be used to validate tokens and validate the signature, make sure that it was provided by a trusted entity, which is Keycloak in this case. And that's where the public keys are going to be found. The token URL is also a Keycloak URL. This is going to be where the agent can perform token exchange. So now the agent, once it receives a token and now it knows it needs to make a call to the tool, it's going to use the received token and make a call, get another token that is downscoped to that specific tool, and we're going to use that new access token. So that is the token URL. And finally, the target scopes are what we need to request along with the token exchange endpoint. So these are the relevant environment variables that we're going to configure for the agent. And from here on out, it's basically going with the defaults. So everything is available at port 8000. We are going to be building from source, meaning we're going to git clone and pull and build from source using the Docker file in the code. So we're going to use the main branch there. This is an A2A agent, so we're going to use the A2A protocol. And finally, we can select some of our preloaded examples. In this case, we're going to use the Git Issue Agent example. And we can go ahead and build and deploy the new agent. So that is building the agent. While we're doing that, we can also go ahead and import the new tool. And after that, we can take a look at the progress with the agent. So the first step is we need to select environment variable sets again. For the tool, we don't need to select anything because there is no model that needs to be called. Instead, we're going to go straight to import.env file, which will come bring these two fields back up again. And we can go back to the documentation and run these two, or add these two to the field. So first, that's the repository URL, and then the MCP env template path. So let's go ahead and click import. And now that we've loaded these environment variables, we're going to go through them as well as we did for the agent. In particular, the upstream MCP, this is just the URL to the upstream GitHub MCP server that is hosted by GitHub. And then we have the required scope, because what this MCP server that we're deploying is going to do is it's going to validate incoming tokens, incoming requests. It's going to validate the bearer tokens that are included. And based on whether or not this scope is included, it's going to use one GitHub personal access token or the other. Now the GitHub personal access tokens, by the way, there is documentation at the top here for how to obtain these. In this demo, we're going to be using 2 personal access tokens. One of them is the public access personal access token, which is going to be used by anyone who can access the tool. And then there's also the privileged access personal access token. And this is going to be the one that has access not just to public repos, but also to potentially certain private repos. And in this way, we're going to be able to demonstrate fine-grained access, where one user is going to be able to use this and the other user is going to not be able to use this. So if we go back to here, as we can see, the first 2 fields are going to be the personal access token that has access to elevated access. So I'm going to go ahead and copy and paste that in to both of these. As you can see, both of these are the same. And the last one is the one to use if this scope is not included in the received Keycloak bearer token. And so we're going to put a different access token which has fewer privileges. So this one is, so just to be clear, this one is different. It's going to have fewer privileges and is going to be the default token to use if the user does not have access to, does not have full access. And the other 2 are going to be the privileged access, which are going to have access to more repos. And you'll see how this looks once we get to talking to the agent. So from here on out, we're going to do the same things. This target port for this application was actually written to talk to port 9090. So we'll put that in there. And then again, we're going to be pulling from building from source from the agent examples repo. We're going to be using the streamable HTTP transport for the MCP protocol. And finally, we can select the GitHub tool example. And with that, I think we can deploy the tool. And now let's go ahead and check in on our namespace, check out the pods. As you can see, the GitHub Issue Agent is running while the GitHub tool is cloning and building. We can let the tool do that. Let's go ahead and look at the logs of the Git Issue Agent. As you can see, there are multiple containers in the Git Issue Agent. In particular, I want to note the main application container is the Git Issue Agent container. And before you even start to interact with the agent, it's a good idea to just go ahead and check whether these logs are included in the logs. This command is provided in the validate the deployment section here. So that's one thing to note. But I also want to highlight some other containers here that are a key part to the security and identity solution that Kagenti kind of provides. In particular, the Spiffy helper is a container that is provided by the Spiffy Spire community, and this is going to be the container that talks to Spire and obtains the identity. So what that does is, from the Git Issue Agent perspective, the Spiffy helper actually mounts this particular file with what's called the JWT-SVID. This is basically the identity document that Spire provides to the agent. And as you can see, this provides a bearer token that was provided by Spire. And from this, we can go ahead and inspect that. And if we inspect that, we see that the issuer is OIDC. This is Spire, actually. And the subject is the Spiffy ID. As you can see, we have details like the namespace, which was dynamically created based on the Spire attestation that was performed, as well as the service accounts. But of course, Spire is very, very flexible and can also have more or less granularity depending on what you need. But anyways, so this is what the Spiffy helper does. And then from there, this naturally leads to what the Kagenti client registration component does, which what it does, if we look at the logs, is first it waits for that SFID. It waits for the Spiffy helper to populate that file. And then it looks at the file and looks for the subject claim and actually registers that client into Keycloak. So if we were to go into Keycloak and take a look at the clients that are here, we can see, oh, the tool looks like it's ready too. So we can see that there are some Spiffy IDs here. The first one, the one that we're actually inspecting, is the Git Issue Agent. And as you can see, this has been registered specifically because of this container. Yeah, so this was the inspection of the agent. Let's go ahead and take a look at the pods again, make sure that both of them are running. Great. We can go ahead and do the next section, which is after we import the tool, we need to configure Keycloak. And now the way to do this is there are actually some handy scripts in the Kagenti repo. I'm going to go ahead and cd to that directory, and we're going to go ahead and export the various environment variables for the script, and finally run the script to configure Keycloak. All goes well, there should be nothing printed out. It should just finish, and we can go ahead and look at Keycloak to see what happened. So let's go ahead and look at what the script should do. The script should first, if you look at the users in the sidebar, you should see that 2 users have been created, the GitHub full access user and the GitHub partial access user. The full access user has all of the roles, has GitHub full access, agent access, partial access, whereas the GitHub partial access user only has GitHub agent access and GitHub partial access. So what this means is that when the full access user logs in and talks to the agent, they should be able to get to the tool, and then the tool should be able to parse that token that was received and look for the full access scope, and based on that, use the privileged GitHub personal access token. Whereas the partial access user is only going to be able to obtain access to the tool, but only be able to access repos based on the permissions of the public access token. So let's go ahead and take a look at this. If we look at the agent, for example, you'll see the client scopes. There are the GitHub partial access and full access client scopes. These are going to be populated into the bearer token for the tool to parse and map to the different GitHub access tokens. So finally, the last thing that you need to do manually, and this is also documented, is to click on standard token exchange and enable it for the agent so that the agent will be able to perform token exchange. So now that we've done this, now that we've deployed the agent and tool and configured Keycloak, we can finally go ahead and run the agent. And the way we're going to do this is first go to the Kagenti UI and log out as admin, because admin actually does not have any of the access permissions to the agent. And now we're going to log in as one of those users. First, we're going to log in as GitHub. Let's start with GitHub partial access user with the credential of password. Let's sign in, and let's go ahead and go to the agent catalog. As you can see, we now have the agent here, and we can go ahead and chat with the agent by clicking on view details. So what we're going to do is first, let's do the sanity check and make sure we can list issues in a public repo. So this is the agent examples repo. This is the repo that we've been pulling all of our code from. And as we can see, hopefully we should get information on all of the issues that were in that repo, because that repo was public and was usable by the public access token. But if we were to go and try to list issues in this private repo that I have created, we should see it fail, because the tool would see only an access token that does not have the proper scope and will only be using the public access, the less privileged access token. So it does not have access to this private repository. If we wanted to make this more concrete, we can go ahead and look at the logs. Because we're in debug mode, this is a very verbose logs, but what we can do is Command F and look at Exchange. And as we can see, first, if we scroll up a little bit, we will have obtained a bearer token. This is what the agent had received. Let's go ahead and inspect this. As you can see, this has a lot of information. In particular, it has the information of the audience, that is the Github Issue Agent, as well as the Github tool, because from the UI you may want to interact with the tool. And it also has the scopes, including GitHub partial access, GitHub agent access, but not GitHub full access. And once we go and exchange this token, if we Control F exchange and scroll down a little bit, you'll see successful token exchange. Let's go ahead and inspect this token, because what this means is we've been able to obtain an access token that was meant specifically for the GitHub tool, because as you can see, the agent is no longer part of the audience. And we can also see that the scope includes GitHub partial access, but not GitHub full access. And this is why we're only going to be able to use the less privileged token. Now instead, now that we've tested this out, let's go ahead and try with our full access user. So we can go ahead and log out. Make sure you log out of Keycloak as well. And we can log in as GitHub full access user, with also the credentials of password. And now that we've logged in, let's go ahead and go back to the agent catalog and run the experiments back. So first, as a sanity check, make sure that we can list the issues of the public repo. And you can see we still have the access to the public repo. And now for the real test, do we have access to the private repo? And yes, we do. We see 5 open issues, something about learning more about Kagenti, or trying out new Keycloak Spire integration features, or reading the new Medium blog. As we can see with this new information, we can see that the different users are able to have different permissions depending on the roles that they have been configured with in Keycloak. And just to be very clear as to why these different users have different permissions, we can go ahead and look back at the bearer tokens. These are printed out in the logs just for ease of use. And let's go ahead and if we scroll up, you'll see obtaining bearer token, and we can inspect this. This is for the full access user, because this is the more recent log. And as you can see, we have the same thing, the audience of the agent and the tool, as well as more scopes. So not just partial access and agent access, but also GitHub full access scope. So this means that we are logged in with more scopes assigned to the bearer token. And finally, we can take a look at the actual token after token exchange, which is going to be used for the tool. And as you can see, again, the audience has been downscoped, which is always good for zero trust, as well as the fact that the scopes now include GitHub full access, meaning that now the full access user was able to talk to the tool via the agent, via the UI, and talk to the tool and use the elevated permissions that comes with being a full access user. And so that is the end of the demo. Please try this out yourself. All of the documentation is available here. And of course, the last thing to do is click clean up the demo, in which I am just going to very easily delete the cluster.